I'm going anyway using English, it's a little bit easier for me. I think you understand me if I were a warm-up band in a concert. I'm coming too late on stage because the stars were here already. Thank you for perfect presentation. My topic is how to manage rainwaters with biochar. And you shared this theme already actually for a bath, because all these growing medias, growing substrates built from macadam and biochar actually are a way to handle rainwater. Our company is named Carbons Finland. I'm responsible for marketing and selling. We are a startup company, grounded 2014, and we started with willow. Our idea was to develop willow-based businesses, producing willow to different and use it in certain purposes. But somewhere 2015, I found this Stockholm case, and we met also several times. And the connection between biochar and willow is that the pore structure of willow is actually the best you can find for biochar, because the structure, different sizes of structure of pores is very ideal. Unfortunately, there's only limited amount of willow to get to produce biochar. We have two different units. One is producing willow in order to produce later from it biochar, and then we have this Carbons Finland. We have two subcontractors producing for us biochar, and we develop it mainly for rainwater management in Finland. The big question is climate change. And climate change means increasing rainfalls, more warm winters, more short winters, more windy. And to handle with these increased rainfalls, of course we need this infrastructure we have already in many places to expand it. But we think that we cannot solve the big challenge related to increased rainfalls. And therefore, our idea is that we could complete the existing infrastructure with decentralized systems. And one part of this decentralized system is these growing beds Björn explained. Especially in cases when we handle actually quite clean waters like rainwaters are, it's easier and more in economically terms efficient to handle these in these decentralized systems tend to collect these rainwaters in water treatment plants. To succeed with systems decentralized, these systems must be rather easy. No chemicals, no technical support, actually no personnel needed, and long-term running time. All these doubts already mentioned here we have been found also with these decentralized rainwater management system related to biochar. It's rather hard to get these accepted in municipal decision making. It's easy to understand actually. Biochar is unknown, only limited amount of references or references somewhere else. And what does it mean if we accept a new tool? I would say that maybe I also would be a little bit afraid to take a new method in use without solid knowledge how long and how well it works in future. But anyhow, some interest is increasing also in Finland. Esko Salo made this map for me, and you see it in poster too. There are only few cases so far in Finland where biochar-based solutions have been built. But interest is increasing, and Björn has been like a godfather for us, explaining carefully for different groups all the ideas related to biochar. I think the very first biochar solutions were built in 2014 or 15, and only one or two. And thereafter, year after year, a little bit increasing. The big difference has taken place during maybe last 2 years when engineering companies get interested in biochar and understood, at least some of them, the idea of decentralizing system completing to the very centralized rainwater management systems. Let's see what happens next year, but there are lots of contacts from different companies, designing companies, how to use biochar, what does it in practice mean when you use macadam and biochar and vegetation on it. That's totally different way of thinking compared to pipelines and pumps. As we heard, porous biochar, porous macadam, there is place for water. And you said something 25-30%. So it means when one tree needs growing media, maybe 25 cubic meter, it can take about 4 or 4.5 cubic meter water. And you can calculate very fast what this means with light rains. 5 trees per hectare is enough to take, let's say, 20 meters rainfall. And that's I think, rather good news when we speak about combining landscape management, landscaping and rainwater management. One doubt related to decentralized water management systems is how long does these structures be active? It's hard to say, but you know that there are places where biochar has been in soil, let's say 2,500 years or something. It's still active. So I'm not saying that biochar alone solves the problem, but it can be very good substitute to the existing systems. And also here, biochar can be a means that you need only once implement in soil. road personnel are rather interested in what to do, what they could do with biochar-based water management systems. State owns the main roads areas, and landowner is responsible for handling these rainwaters. That's one question. The other question is that increasing rainfalls, if the water remains on asphalt, it actually, when temperature is about 0, some minus degrees, some plus degrees, it actually eats up the asphalt, it makes holes. And to keep these roads in good condition, it costs more. We have tests in Finland located near these big roads, and it's amazing how effective this kind of water management system works in two means. Both collecting the water out of road and purifying it. And it's interesting that to see next week I have meeting with road authorities in Helsinki. What is their attitude now? Matthias mentioned these champions. And I have met some, or had about 300 different meetings during last 2.5 years with potential customers, telling about the idea. And I have noticed precisely the same. Without champions in organizations, there is no way to get this message through. After you find soulmate there, they are telling and testing and finding what are the barriers, are the psychological or technical or economical questions that are related to test new methods. Maybe the simplest way I have noticed is this lawn made by Björn somewhere in Stockholm. The basic idea. Actually, these are filters too. This can be used as flooding zones. You can lead the water, and water goes through the macadam and biochar, and grass and vegetation takes up what it needs. Rest remains in biochar, and if something goes through, it's anyway more clear than before. And this can be built anywhere. Now I show you some pictures about quite new process we had in Finland. We are testing here together with a big agricultural organization how this works in rural area, this same idea. It begins with making some trenches. And on the bottom, there's a pipe that collects water after it comes down, and over and under it, crushed macadam, and after it, wood chips and biochar, layer after another. And on the top, macadam that transmits the water from this leading pipe over the filter. Water can come from field, it can come from roads, all areas. And after water has gone through these layers, wood chips and biochar and related microbes. It goes to this collecting pipe and there's a sample well. In Finland we have this, actually seeing from Europe, we are on Iceland and lots of water inside. And therefore, it's very important to get waters going in natural waters clean, collect nutrients up. And big benefit related to biochar and wood chips is that you can take, after these are not anymore functioning, you can take it up and spread it in fields. Background to this idea comes from US. There is Laura Christianson, Iowa State University. She's been testing some 15 years different models related to this, or actually this relates her models, to purify waters going to Mississippi River. And her results are very promising. This functions well in very southern part of Midwest and in very northern part of Midwest, where winters are rather heavy. Next, some new ideas, or for us actually, new ideas about different models or filters using biochar sacks. Here we have a pond that collects water from upwards, and when the water level is high enough, water goes to biochar sacks and in macadam between them, and after it goes to brook or pipe or somewhere else. It can be low or higher, and it's rather easy to make this kind of sacks. We don't have any idea how long these are active, how long these can collect nutrients and pollutants from water. But there are now 2 cities testing this. And if this works, it's rather easy way to build up one filter or subsequent filters to collect pollutants and nutrients dissolved in water before these waters go in natural waters. So that's what they look like. Easy to build and easy to collect and easy to spread on fields or in forests. That's the same idea other way around. We take the water under the filter, so it means that water has longer time in contact with biochar. And afterwards it goes up, we can lead it forward. That's an idea to purify a little lake. It's a recreation lake in Helsinki for swimming in summer and in winter. And that's true. This filter is pulled on a floating and pumping up the water and leading it to these biochar sacks. and if necessary, if possible, you can plant vegetation on it. Vegetation takes with its roots water and nutrients up, or it's only a nice view. But anyhow, that's the one way we test this system. I already mentioned that, and you know that Finland is rather forest-rich country, and forests are playing a big role in our economy, and also the environmental questions related to forestry are important to solve. Now the cuttings are increasing rather, let's say 10 million cubic meters more than earlier, and we have lots of drained forests. And when cutting there, all kinds of nutrients and soil starts to move on with waters. And that's not easy to build any kind of efficient filters in forestry. And this same idea to use these sacs to build submerged dams subsequently, we can slow down the flow speed of water, so it makes rather easy that this solid soil falls down and these sacs collect nutrients in it. This is necessary to function no more than 2 years. And after it, we can spread these sacs in forest. That's one way of using biochar in brook. It is mixed with gravel in the bottom of brook. There is lots of evidence that it should work, but there is no evidence how to change biochar if necessary. I found this text somewhere, and I think that's more than true. And what I like to see is that we all become champions to share and deliver this biochar message whatever we do in normal life. That's a really big thing we have at hand. Thank you.